some information, like all this information, you're going to use in proofs. You're just going to know this is something I know that's true. Okay? That's what these theorems or postulates are. Theorems, axioms, maybe postulates. Yeah, these are just theorems and postulates today. Okay. Anyway, they're just something you're going to use. You will not have to name it postulate 3-1. Nobody has a clue what that means. But you will use the word same side interior angles. Don't you know what same side interior angles are? And you're familiar with those words? So those are the words that we will use. Now, what we know about them is that if they are same side interior angles, they actually add to 180. It's like they are a linear pair. Does that make sense? So now we know this to be true. If I give you a transversal, these lines are parallel. Do y'all see this little triangle right here? You might not. There's this little red triangle that's doing like that. Do y'all? Okay, that means they're parallel. That's just a little symbol for, hey, these lines are parallel and this line is cutting through. And they're telling us that angles 3 and 6, they add up to 180. And you know what else? Angles 4 and 5, they add up to 180. We just know that. Is everybody good with that? We'll use it. We'll use it with math problems and we'll use it with proofs, which y'all probably don't just love. Okay? And it's called same side interior angles. Yesterday you learned what they are. Now you learned that they add to 180. Okay? Can we keep going? All right. So let's do this one. Let me cover this up. Can I use that? Yes. Okay, so we do have a little math problem with this one, and then we'll do some proofs. All right. Do we what?
A sheet today?
Yes, you do. All right, it tells us, let's read it, that angle 3 is what? 55. Which angles are supplementary to angle 3? So if angle 3, I'm going to write that is 55. Okay, what does supplementary mean? It adds to 180. So what did we just learn? What angle will be supplementary to angle 3?
8.
Angle what?
8.
8. Because those are same side interior angles. What do we know about same side interior angles? They add to 180. So angle 8. Do y'all know another one that would add to 180?
2 and 5.
Yes, but let's just look at 3. 2 and 5 would add to 180. But if we're looking at angle 3, which is 55 degrees, what's another angle from a long time ago that we would learn that would add to 180? Anybody? I actually see 2 more angles. If this is 55, it makes a straight line with another angle. What angle?
2.
Angle 2. That's not the first one I thought of, but yes, angle 2. Angle 2 and angle 3 would add to 180.
Like, where did 8 go?
Because it said, okay, you know that angle 3 is 55 degrees. What angle is supplementary to that? Angle 8. We just learned that. Same side interior angles add to 180. It's like our new rule. It's our new theorem or postulate. Okay? So angle 8. Then Riley remembered that angle 2 and 3, those are a linear pair. So what do they add to? 180. So angle 2. And there's one more. That's a linear pair.
Angle 5?
Mm-mm.
Are you talking about a pair?
A linear pair. What adds to 180? Huh?
5 and 8?
No. With angle 3. 4. Angle 8 and 3 are supplementary. Angle 2 and 3 are supplementary. Angle 4 and 3 are supplementary. Does everybody see those things? 2 of these 2 right here, we learned 2 chapters ago. We learned that a linear pair adds to 180. That means supplementary. Right? Okay. Today we learned that angles 3 and 8 add to 180. Those are same side interior. Is this kind of coming together now? I'm about to show you a trick here in a minute. So everything on this transversal, big hint, they either equal each other or they add to 180. They either equal or they add to 180. So let's fill them in. If angle 3 is 55, can anybody tell me what angle 4 is? How do I find it? They add to 180, so we subtract. What is 180 minus 55?
125.
125. Does everybody understand that angle 4 is 125? What else is 125?
Angle
Angle 2. And what else is 125?
2. Angle 8.
Okay. Now, we can fill out the whole thing just knowing one angle. What do we know about angle 8 and 7? They're a linear pair.
So that's 120. That's
They
55.
add to 180. So that one is 55. What do y'all know about vertical angles?
89.
Vertical angles are what? The same. So if this one's 55, this one's 55. If that one's 55, that one's 55. If that's 125, that's 125. We've only got two numbers. They're either equal or they add to 180. Okay, does everybody kind of understand this? It's the same pattern every time with the transversal. The same pattern. Alright? But what we know is same side interior angles add to 180. Does this make sense? Okay, look, let's do 30. Pick a number. 1 through 8. 7. Okay, angle 7 is 30 degrees. What other angles are 30 degrees?
Angle 5.
Angle 5. Okay, if you don't know the others, that's fine. Now let's back up. What are angles 6 and 8? 150. How'd you get that? They're a linear pair, so they add to 180. 150, 150. Now, this is what we know. These are same side interior. They add to 180. So what's angle 3? 30. Now you know the rest. That's also 30. That's 150. And that's 150. Okay? We can use all that information. We can know one angle and know everything else. Okay? So vertical angles are congruent. Same side interior add to 180. Alright? What do you know about alternate interior angles now without even learning it? What do you know about alternate interior angles? They're equal. What do you know about corresponding angles? They're equal. Okay? So you just found out those rules. We're about to learn those rules next. Okay? So, just looking at a transversal. Have y'all ever seen this before, a transversal? No? Some younger grades learn it. I thought. Maybe not. Okay, so let's see. Here is your next little proof. I mean, not your proof, sorry. Your next theorems. We just said this. Alternate interior angles are congruent. Yes. Okay? And corresponding angles are congruent. We said equal. That's the same thing. So that's all this means. Alternate interior angles, they're going to be congruent. And corresponding angles are congruent. Do we kind of understand that? Let me see if I can take that glare. Is that better? Or is that worse? Okay, it took the glare away. I know it's darker. But it's saying that 1 and 5 are equal. 4 and 8 are equal. 2 and 6 are, or we can use the word congruent. And 3 and 7 are congruent. Okay? Now let me see what else we have. I'm not a fan of today's paper. This, I think. Okay, let me see. Is anybody still writing that? No, nobody's writing that. Let's go over. Let's go through this theorem. I meant this proof. Okay, it's because y'all hate proofs. I'm gonna give y'all part of it. Normally I don't. Sometimes we have to write them from scratch, but we'll go through this one step by step. Okay, it tells us that A and B are parallel, and we have this line that cuts through them. That's a transversal. It wants us to prove that angles 1 and 8 are supplementary. What does that mean? Angles 1 and 8 are going to add to 180. So let's use some information. It says that A is parallel to B. That was, how do I know that? It was, what word is next to that? A is parallel to B. Given. That was given to me, so I write the word given. Why are angles 1 and 5 congruent? What kind of angles are they? Huh? Corresponding angles. I would not say all that they said. I would have just, on angles 1 is congruent to angle 5, I would have put corresponding angles. That's all I would have written there. Okay? So, what does the next step mean? The measure of angle 1 equals the measure of angle 5. That's just definition of congruent. I don't know what they put. Yeah, I just say definition of congruent. If they're congruent, what does that mean? They equal. So for number 3, I would have put definition of congruent. 5 and 8 are supplementary. How do we know that? How do we know that 5 and 8 are supplementary? They add to 180, but why do they add to 180? Because they are a linear pair. I would put, oh, that's what they put. They're a linear pair. Okay? You don't have to put are supplementary. I would just put a linear pair. So then it says the measure of angle 5 plus the measure of angle 8 equals 180. Well, that's the definition of supplementary. Let me see if I can get that off of there. There it goes. Okay. The measure of angle 1 plus the measure of angle 8 equals 180. So what did they do? This part's confusing. I know you might can see it. Instead of writing 5, what did they write? 1. They substituted it in. Didn't we say right here that 1 and 5 are the same? So instead of writing 5, they wrote 1. So that's substitution. So angle 1 plus angle 8 equals 180. That means they're supplementary. Definition of supplementary. How was that? It's kind of explaining every step. Proofs are terrible. Yes, they are. Let me see what else I have. Oh, did I not? I did not do. Oh, I'm so glad I did not. I need to throw these away. I did not print y'all's paper, which is a good thing. I think let us go through a few proofs together, and then I kind of like some of these. We might just kind of practice stuff. Let's see. This one right here. Okay. This is different. All right. This might be like what's on your test. We're going to try and do this one. We are trying to prove that 4 and 6 are congruent. 4 and 6 are alternate interior angles. So we cannot use that as part of our proof. We're trying to prove that they are congruent. So the first thing that they give us is that L is parallel to N that's given to us. Why are angles 2 and 6 congruent? They are corresponding. I can use that one. Okay? Angles 2 and angle 6 are corresponding. So that's what I would write right here. Corresponding angles. Sorry, I was going down. Okay, why are 4 and 2 congruent? Y'all know that. They're vertical angles. Does everybody see that? These are all things we've learned. Nothing new. Vertical angles. Now, I'm trying to prove, so I've got 2 and 6 are congruent, 2 and 4 are congruent. I congruent use alternate interior angles. Okay, I'm trying to prove that. It tells me you can't see that in directions. But let's follow our proof now. If 2 is congruent to 6 and 4 is congruent to 2, then 6 is congruent to 4. What property is that? Yay, it's transitive. It's transitive property. That's like, this is like the most common proof. These are the most common things that we'll use. Transitive properties. There you go. How was that one? Was that one bad? That one wasn't near as bad, was it? No. Okay, so you just proved that alternate interior angles are congruent. Okay. Let's see if I have another one that I want to go over. We leave in 5 minutes?
No.
Oh.
He asked how many does I killed yesterday.
Oh.
That's not to do with math.
I thought you said we leave in 5 minutes, and I was like, what?
That would be-
Oh, we gotta go over this some more. All right, anybody still writing that? Oh, were you writing that still? I'm so sorry. Look, there it is. I'll find the next problem. Okay, let's see.
So your first one is -3. Then you have to roll -3.
Are we done? Not yet? I gotta look for another proof. I think I want to do. We'll do one that's not a proof for a second. Okay, let's see. Let's look at a few of these problems. Ignore the one on the right. Put this back up. I'm going to do another proof in just a second. We're kind of going back and forth with some proofs. So, let's look at number 1. It says identify all the angles. What is every single angle up there? Angle 1, 2, 3, 4, 5, 6, and 7. I have to know all of them. So, just given one number. The easiest one, what's angle 3? 132. I'm going to cover that up. 132. Do y'all know what angle 5 is?
132.
Also 132. And what's angle 7? I would just go through and write all of those first.
And then number 6 would be
So how do you find the last one? How'd you get that?
180 minus 132.
And what is it?
28. Wait.
Yes, that makes sense.
Wait,
No, I'm thinking of 150.
150. So it's
30 plus 58. No, 48.
48. Isn't it 48?
Yes.
Y'all double check us.
Yeah,
I get 48. It is, yeah. So you subtract though. 180 minus 132. That one would be 48.
Okay.
That one would be 48. 48 and 48. Remember, it's they're either equal or they add to 180. It's the same thing over and over. We've only got 2 numbers up there. Let's look at number 3. If this angle is 88 degrees, what's angle 5? 88. What's another one that's 88?
2. No.
No.
1.
Yeah. And?
So it's
3.
9
3.
minus 18 minus 27.
So the rest would be
92.
92.
My brain's
92.
working right now.
92. 92. 92. Is everybody good with that? We'll add in a little algebra now. Okay, everything is just equal or it adds to 180 and it's the same pattern over and over again. Okay, I'm going to erase. Can I erase? Not yet.
Negative. So it made it positive. And then yours is negative, so it makes and yours is positive.
I'm gonna skip to number 9 in a second. Are we ready? Okay, let me move it up. Ignore scratch work on the right. Oh, nope, we're gonna do number 9. There it is. I think we'll do 9 and 10. Now, these don't look like transversals. They actually just made them look a little more difficult. So I'm gonna draw my transversal in blue. That means this line is parallel to this line. Do y'all see that? How did I know those were parallel? Because they had that weird looking triangle mark.
You see what I'm saying?
Alright, what line cuts through it?
Oh,
That one. Now it looks like a transversal. Do we see the transversal? Are these angles equal or do they add to 180? It's one of the two. They're either equal or they add to 180.
Which ones?
X and X minus 26. They add to 180 because they are called what kind of angles? Same,
Side.
yes, same side interior angles. They add to 180. Do y'all remember this? We learned that today. So X plus X minus 26. If I add those two things together, they equal 180. What do I do now? Not yet.
I don't know.
We,
Add
what's
Define
X?
your X's, so it's
X plus X, no, not X squared.
Not
X
X squared.
plus X is 2X. Then what do you do?
Then,
Add, somebody said
You
it,
add
add
26.
26?
then you divide.
Yeah, there you go. So we get 2X equals,
Try 9 plus
106. 206.
206.
9, 9,
And then, wait, I got you.
103. 9,
Yep. 103.
I knew that.
I think that's what it asked for. Did it ask for X? Yes. Oh, find the value of X or Y. We don't have a Y in
X
that one.
equals 103.
Now we have
Okay, then, what?
Yeah, put positive and minus
Measure it.
26.
Find the measure of the
So
angle.
you plug it in.
So what is this one? Well, that one's easy.
106.
It's
I had to put
103.
together
The next one is,
easy stuff like that.
103
83.
minus 26
No.
should be 77? How did we get 70?
yeah.
Well, I don't want to put that right here, that'll be confusing.
Okay, so minus 26 from X, and X is 103.
Yeah. You could do 103 minus 26, or you could do 180 minus 103.
Is the reason that line, like
There should be
the
more to it.
one that cuts through it, is that because all those numbers are on that side?
What, this one right here? Well, the reason I drew it like that is because we know, today we learned about a transversal. A transversal is parallel lines with a line that cuts through it. Well, this looked like a parallelogram. It didn't look like a transversal. So I wanted to say, okay, here's our two parallel lines, let's cut through it so we can see it as a transversal. So that's why I drew that there. Now you know those add to 180. I don't know if it was just to kind of help you see the transversal. Because without that, to me, it looked confusing. It just looked like a shape. And what do I know about shapes? We don't know that about shapes yet. We will know that soon. We're going to learn a lot of stuff about shapes. This one's the same thing. If I, anybody still writing number 9? Because I'm about to do number 11 in just a second. Number 11 is another shape. I'm not familiar with rules for shapes, but I am familiar with a transversal. So I'm going to draw my transversal in just a second with it. This may be our last one. I thought I had a paper today, but I'm glad I didn't
Yes.
because we'll finish this tomorrow. We're going to do more proofs and more of these
The proofs
tomorrow.
aren't as hard on these. The other proofs were hard.
I've got some proofs that are kind of tough, but on here, that's why I didn't give you that paper. I'm kind of glad I did not give you that paper.
Thank you, Ms.
All right, let's see, 11.
So for the next one,
You are.
wait, this is a.
Okay, let me move it up, and here we go with number 11. See, 11 is a shape. I didn't learn shapes today, or you didn't.
And that's right.
So let's make it a transversal. Let me draw my parallel lines. Boom, and
And then you plug 0.
boom. Is everybody good? Everybody good with those parallel lines? Now, let's draw the line that cuts through it. Which line is it going to be?
And then you plug the 0 inside.
This one right here.
Yes,
So this angle is x plus 55, and this angle right here,
Yeah, this is the next one.
it's pointing to it, is 3x minus 5.
0 squared plus 4.
What kind of angles are those?
0 squared plus 4. Right angle?
Not- So are they same side interior, alternate interior, corresponding or vertical?
Same side as here.
They are on the same side, but are they both on the inside?
Same side alternate.
They're corresponding. Corresponding, what do? They skip.
Minus 27.
Remember? Those are, what do we know about corresponding angles? They either add the 180 or they're equal. That's what I said. They either add the 180 or they're equal. They're equal. Corresponding angles are equal. This one right here and this one right here. So I would write 3x minus 5 equals x plus 55. Is everybody good with that? Yes, no? Remember, it's either going to add the 180 or it's going to equal. You have to decide which rule it is that we use. So how do I solve for x? Yep, we subtract x from both sides. So 2x minus 5 equals 55. Then what? Add 5. So 2x equals 60. Then what? Divide by 2, and x is 30. And it asked me for x, and it also asked me to find each angle. So what is 30 plus 55? 85. And if this one's 85, then what's the measure of this one? It's also 85. Because corresponding angles are equal. Is this starting to come together at all? A little bit. Tomorrow we'll do more proofs and more of these problems. Okay.
So we're done?
Yeah, I think we've got like 4 minutes left. Let me stop the video. Let them finish